Alright, in this video we're going to be talking about some very special trig values. These are those that many teachers ask students to memorize usually to become more fluent in a trigonometry class. I have my trig values organized into a table that looks like this, but before you get overwhelmed, I'd like to show you that this table contains a lot of related information and some ways to produce it quickly, even if you forgot some of the values that you would otherwise know. So starting from scratch, we want to create a subsection of the table that you just saw, and it's going to contain just the basic angles and trig functions. Here we're looking at sine, cosine, and tangent, as well as the significant angles between 0 and 90 degrees, or 0 and pi over 2 radians. And these happen to be the ones that are found in the 45, 45, 90, and 30, 60, 90 right triangles. And to remember these angles, you could convert between degrees and radians using a proportion like this, but I'm usually able to just remember them because of the repeated numbers. You see the 6 and the 3 and the 4 are all repeated. The 4s end up matching up, so the 45 degrees and the pi over 4, and the 3s and 6s are reversed. 30 degrees matches with pi over 6, and likewise for 60 degrees and pi over 3. You'll be using these angles so much that soon enough you're just going to know what they are. Now we have to start somewhere, and a long time ago I noticed a pattern in the values in the sine row, and that pattern was that they all have this square root of something over 2. From left to right we can start with 0, and we're going to get the square root of 0 over 2, the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2, and the square root of 4 over 2. So 0, 1, 2, 3, 4 on the tops inside the roots, 2 always on the bottom. These values though are not simplified yet, so we can say like the square root of 0 is 0 and 0 over 2 is 0. The square root of 1 is 1 and we get 1/2. The square root of 2 over 2 and the square root of 3 over 2 are both as reduced as they can possibly get, but the square root of 4 is 2 and 2 over 2, or anything divided by itself, is 1. And thus we have a simplified set of values for the first row. Now you may know that sine and cosine are what we call cofunctions. It means they have the same values when their inputs or their angles are complementary. So based on the way the table is set up, if you were to compare the angles starting at the left of the table with those starting at the right of the table and create pairs, they are pairs of complementary angles. In practice, this means that the values of the sine function from left to right will be the same as the values of the cosine function from right to left. So if we go ahead and fill in this table, starting with the left on the sine and the right on the cosine row, we would have 0. Continuing on, we could put in the 1/2 into our cosine row, again, moving from the right side. We could meet in the middle and actually have the same value of root 2 over 2, and so on. Now we have 2 complete rows. To form the tangent row, we're going to rely on one definition or identity involving the tangent. That is that the tangent of an angle is the sine of that angle divided by the cosine of that angle. Now for 0 degrees, we're going to form a fraction made up of the values in the sine and cosine rows just above it. So we're going to have 0 over 1. That, of course, is just 0. And that's our simplified value for the value of tangent at 0 radians. In this square, the tangent is going to be 1/2 over the square root of 3 over 2. We're going to simplify this in a moment, but temporarily let's just hold off. Here we're going to create the fraction root 2 over 2 over root 2 over 2. And since anything divided by itself is 1, that's the value we're going to get. For pi over 3, we can use the values of sine and cosine to write this fraction. And like that pi over 6 column, this one's going to take a little bit of work to simplify, but now seems like the right time to investigate that. First, we can write the fraction, but instead of as a fraction over another fraction, we're going to write it as a fraction divided by the second. To divide, we're actually going to multiply by the reciprocal, and the 2's are going to cancel. Now, you may notice that these 2's were the denominators of the smaller fractions in our original complex fraction, and that the numerators from this fraction make up our solution. We have the root 3 over 1 left to go, which is just the square root of 3. If we remember this kind of pattern, it's going to save us some time simplifying later. We can replace this complex fraction in our table with the square root of 3. And finally, in this column, our fraction becomes 1 over 0, which is undefined. And we do have to go back to the square that we skipped. We said earlier that the fraction was going to be 1/2 over root 3 over 2, and you can notice that the denominators are similar like they were just a few moments ago in the pi over 3 column. As a shortcut, they're going to cancel, and we're going to end up with these remaining numerators as our fractional answer. We're going to get 1 over the square root of 3. Now here's the work that would produce that, but our solution can be considered 1 over root 3. Unfortunately, this isn't simplified. There's a root in the denominator. We'll need to rationalize. We do that by multiplying by 1 in the form of square root of 3 over 3. Something that's going to get rid of the root on the bottom. This is going to give us the square root of 3 over 9, and the square root of 9 is 3, getting rid of the root in the denominator like we wanted to. And that's going to be our simplified value. Now, to continue on and find all the values, we're going to focus on 2 other angles. We have 180 degrees or pi radians and 270 degrees or 3 pi over 2. These, in addition to 0 and 90 degrees, which are already in our primary table, form the quadrantal angles, or those that represent the positive and negative x and y axis of an angle in standard form. 0 and 180, because they're both forming the x-axis, are going to be linked in a way, and so will 90 and 270 degrees. So if we focus on the x-axis, 0 and 180, these are going to be very much related. The catch is, since 180 is on the opposite end of the x-axis, I remember that the values for 180 are going to be the opposites of 0. Exactly the same values, just opposite. So the opposite of 0 is actually just 0. The opposite of 1 is negative 1, and the opposite of 0 is 0. If we then go ahead and focus on the y-axis, 90 and 270, or pi over 2, 3 pi over 2, are going to be linked as well. They're going to be opposites. So the opposite of 1 is negative 1, the opposite of 0 is 0, and the opposite of undefined is still undefined. Which leaves us with the reciprocal functions. And that's one of the relationships that we're going to work on. The cosecant function is the reciprocal of sine. Reciprocal, we can raise those values to the negative 1 power, or we can put them as 1 over the values that they are. Either way, we can use that information to simplify and come up with values for the cosecant row. As far as the 0 radians looks, I'm going to treat that one as 1 over 0, which is undefined. For the pi over 6 row, I'm going to consider that the reciprocal, or flipping the fraction. 1/2 becomes 2 over 1, which is 2. Similarly, we can have root 2 over 2 flipped to become 2 over root 2, and there's nothing wrong with this aside from the fact that it has a root in the bottom, so we can rationalize just like we did a little bit earlier. We'll multiply by 1 in the form of root 2 over 2. It's going to give us 2 root 2 over 2. The 2's are going to cancel, and we get the square root of 2. We'll put that into our table and move on. For the pi over 3 column, we are going to flip this guy upside down, and following a similar rationalization process, you can trust me that this is going to be 2 root 3 over 3. For the 90 degrees, or pi over 2 column, the reciprocal of 1 is itself. For 180 degrees, as we continue in our table, the reciprocal of 0 is undefined, and the reciprocal of negative 1 is still negative 1. To figure out what the secant column is going to be, we could actually look at one of two different properties. The first is that cosine and secant are reciprocals, and the other is that the cosecant and secant functions are co-functions, and you hear it in when you say them, secant and cosecant. So we could use either of those two techniques that we've used in the past. I would prefer for at least the left portion of this table, for the 0 through 90 degrees section, to use just the reverse of the cosecant row. So starting from the left on cosecant is the same as starting at the right in secant. So we would go undefined 2 root 2, 2 root 3 over 3, and 1. When we look at 180 degrees, I'm actually just going to use the reciprocal function cosine. The reciprocal of -1 is -1, and for 3 pi over 2, the reciprocal of 0 is undefined. So we're getting closer here now to look at the last row, the cotangent row. We can compare this to tangent. Those are reciprocal functions, but they are also co-functions. So it's the only pair of functions that are their own reciprocal and their own co-function. Or maybe not their own, but each other's. So again, for the values in the 0 to pi over 2 range, I'm just going to go backwards from what I see in tangent. We'll start with 0 on the right, root 3 over 3, 1, root 3, and undefined. And then use the reciprocals for 180 and 270. The reciprocal of 0 is undefined, and the reciprocal of undefined is 0, necessarily. So we also should acknowledge that even though this table is complete, there are a lot of values in between 90 degrees and 180, and 180 and 270, and 270 up to 360, or even beyond that. And for a majority of the values that are inside, we're going to use what are called reference angles, and the values 30, 45, 60, as well as coterminal angles, meaning they are a full rotation away from one another, and they're going to have the exact same trig values. So while every angle, for example, 25 degrees is not represented in this table, these are what we would call the special angles. And using that technique, you could produce this table and use it to obtain a lot of different trig function values. Hope this has helped. Have a great day.